Hi guys, it's Scott here, and in today's video we're going to introduce you to a typical sandcasting process. So where does sandcasting fit within the scope of all the different manufacturing processes available to us? Firstly, we have the forming methods, and within these forming methods we have both casting and reforming. Casting is a process where we take something that is liquid, sometimes a metal, sometimes a plastic, and then we pour it into a mold and then let it set so that it hardens, and then we take out the part, which we can then do further processing on and machining on to bring up to the final desired standard. So sand casting is one of the most common forms of that casting process. There's also things like shell molding, die casting, investment casting, and quite commonly with plastics, injection molding. So sand casting is the focus of today's video. Within these forming methods, we also have some reforming options, such as forging, and then we get into the machining methods, which we're going to take a look at in future videos, and then joining methods, some of them permanent and some of them semi-permanent or temporary. So today's focus is sandcasting, so let's look at a typical sandcasting process. Sandcasting is the most straightforward way to make metal objects with complex internal cavities in high volumes and medium quantities of objects with complex external profiles. So if we look at this picture on the left here, this is actually an exhaust manifold cast out of iron that you would typically find on a lot of your production cars. And so the hot exhaust gases exit out of the head of the engine through these ports and are collected together and go down and flow on into the exhaust system of your car and your muffler and your catalytic converter. And this geometry has quite a complex shape, and it's got a lot of internal cavities here for the exhaust gases to flow through, and it also gets quite hot, so it needs to be, the material we choose has to be resistant to those high temperatures, and there's also an exhaust system hanging off this, and so it has to be reasonably structural. So in this kind of circumstance, cast iron is a very good option for these types of parts, and we can make them relatively cheaply and in high volume. This is all cast in one piece, and then we perform some machining operations to flatten some of these surfaces so that they can bolt up and seal nicely against the head of the car and also against the exhaust manifold. On the right hand side here we have an example of a cast engine cylinder block. So this is something that you might typically find in a motorcycle, and you can see that it has a lot of complex fins on the outside, probably because this one looks as though it's air cooled, so it doesn't have water jackets and cooling water flowing around the engine. The heat is actually dissipated from this engine via air cooling from these fins. And so this has quite a complex external profile, and this would take a little bit more time and effort to set up for this casting, and so we can't do it quite as easily as the exhaust manifold, but it's still possible to manufacture medium quantities of parts, complex parts like this, using the sand casting method. And if you have a look at this, this is actually cast from aluminium. You can tell by the color of it, it's a lot lighter than the cast iron example over there. Like the exhaust manifold, this engine block would be cast in one piece, and then there's going to be some very highly precise machining operations which are performed on the bores, these cylinder bores here, to bring them up to the correct tolerance for the pistons to work within. And then it's also got holes drilled and probably tapped to take studs which would bolt down the head of the engine. So these are a couple of typical examples of parts that are commonly manufactured using the casting process. We're going to use the following diagrams to talk you through a typical sand casting process. So the first step is for us to develop what we call a pattern. And a pattern is basically a reproduction of the part that we want to actually manufacture with a few small changes. So this is a wheel that we're making here, which is quite solid, and we can see that there's a bit of a boss on this wheel here, and we've also got something on the tip there called a core print, and we'll talk about that in a second. So these patterns can be made a variety of ways. Commonly they're made from wood because wood's nice and easy and quick to work, and it's reasonably durable. If we wanted to make a lot of these parts, then we might make our pattern from something a little bit more wear resistant, such as aluminium or steel. And in this case, due to the casting process and design that we've selected, this pattern for this wheel that we want to make has actually been split down the middle. So there's actually two pieces, and that's going to enable us to build the sand around of our pattern so that we can then pour the metal in and form the shape, and also have a little bit of a runoff here for excess material, excess metal to go into here to make sure that our part is completely full and we don't get any air trapped in there. So in this particular process, we're starting with a half pattern, which is this one here. So the pattern splits in half, and we're going to place that on a horizontal molding board, which you can see here. And so we'll put this pattern down onto the molding board, and then we place what we call the drag. So the drag is this component here, and it also has this lip which goes around the side there, as you can tell from the cross hatching. So if we put that on there, the drag is actually a four-sided box which fits very accurately to this molding board on the base. So if we put that around there, we can then start filling up this region above our pattern with the sand. So we'll put that in and we'll compress that down with a tamp, and we'll build the sand all the way up to the top of the drag, which is up here. Shown in this picture here is an example of a pattern which is split in two. So it's a different shape to the wheel that we've got in this diagram, but you can see that it's made of wood, and this is one half of it down here, and this is the other half, and they join together via some holes and some pins to ensure that when they're assembled together that they're actually mated up correctly and there's no gaps or overhangs on these edges. So we've placed the drag on top of our mounting board, and then we go about putting on the sand and then ramming it down, tamping it down until it's nicely firmly compacted and there are no air gaps, and we fill that all the way up to the top of our drag. And then once we've done that, we actually flip the whole thing upside down and we turn it over, we put it on the table, and we take off this mounting board. So in the second image down here, in the middle image, we've actually turned this top image upside down, and this is another mounting board or a table, and then we can actually remove this mounting board from off the top of here and take that out. We've then got the second half of our pattern, which we can add onto the top of the first half, so that we've now completed the cavity that we're building for this part. And then once we've got the second half of our pattern in place, we can add on what we call the cope. So the cope is this piece that we've got here, which is another square box, which we put on top of the drag. At this point, it's usually a good time to put in what we call the sprue pin. So this is a sprue pin pictured here. This may be a solid rod or it may be a hollow tube, and the purpose of the sprue pin is to create the entrance for the metal that we're going to pour into this mold. So we need to actually account for that when we're building this, and it's easier to mold it in at this stage rather than to dig a hole for this one later. And so we're going to place that sprue pin in there so that later we can make this pathway for the metal to flow into the mold that we're creating. We might also have a riser pin which might be added in here that's not shown in this diagram, but this would be the point that we could add that in there as well, and there might actually be a recess in our pattern to be able to hold that riser pin in place when we put the next lot of sand in. I should point out at this stage an important reference plane. So this is what we call the parting plane through the center line of our part here. And so it's very important to understand where your parting plane is and think about where your parting plane should be so that we can cast our part accurately and we can get the part out that we want with the minimum amount of manufacturing imperfections and wasted material. So this is our parting line here where the two halves of the mold are split. So once we've got all the bits and pieces in there, before we put in the second lot of sand, what we're going to do is we're going to go around and sprinkle all of the exposed surface with either some dry sand or something like talcum powder. And the point of this is to create a mold release. And so we don't want these two halves, the sand in the two halves, to stick together. We want to be able to separate them because we need to split this mold to be able to take out the solid pattern that's in there to make room for the metal. So we need to make sure the sand and the pattern is going to come away from the sand up here easily without breaking up our mold. So we'll sprinkle that sand or that talcum powder in there, and then once we've done that, we're able to start packing the sand up from the parting line so that it fills up to the top of our cope and it's fully full of sand at that point. And then we can take out our sprue pin, and if we've got our riser pin, lift them out of the mold. And then what we need to do is separate these two halves. So we'll carefully lift this up, and all the sand will be stuck inside there. The sand that they actually use for this type of molding is kind of like beach sand. It's got a little bit of moisture in it, so it kind of sticks together and you could build sandcastles from it. And they also put a few other additives like clay and sometimes a little bit of resin powder, so that it'll hold together when we're actually forming our sandcasting patterns. And then when the hot metal hits it, it'll actually form a nice hard shell, a barrier, to prevent the metal seeping into the rest of the sand and getting stuck in the part that we're making. So once we've split these two halves apart, we take out our pattern, and we've taken out our sprue pin and also a riser pin if we've got it in there, and we're nearly ready to go. The only thing that you might notice here is that we've got something called a core. So this is the core here, and this is a piece that we can mold separately, and we can make this actually out of sand, like a tube of sand mixed with some resin, so that it's quite hard and it'll hold its shape, and we can put it into these patterns. And the point of having this pre-made core in here is that that fills up a region that would otherwise be taken up by the metal as it pours in here. So it can be used to make a hole into our part, so that that will simplify and speed up our machining process later on. We won't have to drill a hole all the way through here and make it bigger. We've already got a hole that's pretty close to the size we want, and so we just have to clean up that surface a little bit and take it up to the dimension we're after. The only thing is, this core can't just stand inside this pattern on its own. It might float around, or the entry of the metal might push it out the way. So we need to allow a small space for these cores to sit in, and this is the reason why we had this core print, as it's called, back up here. So this is a little bit of an extra we've added onto our pattern to later make a cavity, so that we can put this core in there, and that'll be held rigidly in position during the casting process. If I go back to this image here, we can see this is how you might go about making a pre-made core for the shape that I showed you earlier. So if we want some cavities within this tube with a cylindrical end, this is a box we might use, and that's actually a recess, and we can fill that with sand with a mixture of resin and clay in it, and we can bake that in the oven and remove it, and then this can be used in our sand casting process. These are examples of pre-made cores here. You can also buy common size pre-made sand cores basically off the shelf in a range of different dimensions. So this is what a completed box might look like. We've got one side which is the drag, and one side which is the cope. We've placed our pre-made cores into this box here, so they're held in position via the core prints at the end of each of these parts. We've got a couple of horizontal cores there, and we've got one vertical core here. And so when this is joined back together, this part here matches up with this part here. This one here matches this one here. This one goes over to there. And then this part here doesn't have any indentations on this side. So this is what we call a one-sided pattern. All of the features of the part are on this side only, and then there's a flat surface on one side of it, and it's got a vertical core which sits there. Depending on how many parts you want to make, sometimes it's more economical to cast multiple parts at once, like we're doing here. So we would pour metal into the center of it, and the metal runs out through these gates and into these 4 parts. And then once we remove the sand, once everything's cooled, we can break these parts apart and cut off the excess material and finish machine them until they're ready for whatever purpose we've intended for them. One thing I should point out, a little step that I might have overlooked, is that when we have our sprue pin in here, you can see that there's not a complete pathway from the recess that this sprue pin is going to make through into the part. So when we split our mold, we need to actually cut out what we call a gate, and that gate runs between the sprue and the cavity of the part to ensure that the metal can run in there. If we don't make that, then the metal's just going to pull up when it hits the bottom of this sprue cavity. So we've done that, and then as the metal flows in and fills up, hopefully pushing out all the air and not leaving any air cavities in high spots like this, the metal will then rise up the riser. That's why it's called the riser. And as the metal cools, it's going to shrink down, and that'll give it a little bit of excess material to draw from so that it doesn't crack and wrinkle. And so that's the purpose of having the riser there. It also helps us see when the mold is actually full of metal. It'll start coming up here, and that means that you can stop pouring metal into the sprue over here. So once we've got the two parts back together, we're ready to start pouring the metal in, and then once it's all solidified and cooled down, we can take it apart and pull the part out and wash it off to clean off all of the sand, and then we can actually recycle the sand and use it again in our upcoming jobs, and then take the part off and machine it to the finished standard that we require. So that's a basic look at a typical sand casting process. In the next video, we're going to show you this illustrated using some real examples.